Okay. Today we're going to talk about graphing quadratics from vertex form. So I would like for you to first recall when we were graphing absolute value equations. The form that we used when we graphed those was technically vertex form. So if we were trying to graph f of x equals the absolute value of x plus 1 minus 2. So remember, your f of x is really just your y. And we were able to easily locate the vertex of this because the x-coordinate of the vertex was just the number that made this 0. And then the y-coordinate of the vertex was just this number hanging out on the end. So my vertex was at -1, -2. Okay, and if you don't see the x-coordinate of the vertex easily, then all you do is you take this and you take it out and you set it equal to 0 and you solve it by subtracting 1 from both sides. That's how we get the x-coordinate of the vertex. And then the y-coordinate of the vertex is whatever number is here, that's the y-coordinate of the vertex. If there is no number there, then it's going to be 0. If there is no number added or subtracted to your x, then the x-coordinate of your vertex is also 0. So then we were able to go ahead and graph this, plotting our vertex, -1, -2. And then in order for us to find some other points, all we did was pick an x value and plug it in, make a t-chart. So if you plug in x equals 0, we will be able to find a point over here. So if I put 0 in, I would get y equals the absolute value of 1, which is 1, minus 2. So y equals -1. So then we were able to plot that point 0, -1, and then reflect it over to the other side, because that absolute value, which is always a v, has that axis of symmetry running right through it, just like your quadratics do, your parabolas. And then we were able to go ahead and graph those and make a v. So what we're going to do today is very, very similar. We're going to graph from vertex form, so we're going to easily find our vertex the same way we find it with our absolute values. But instead of finding these other 2 points by making a t-chart, we're going to solve by taking square roots, and then we'll be able to find the x-intercepts. And then we'll also go in and find the y-intercepts, and then go ahead and graph our parabolas. So there are 2 ways to find the vertex. If it's in standard form, we're going to use that little formula, x equals -b over 2a, like we did when we first introduced our quadratics. If it's in vertex form, which this here is considered vertex form because you have a quantity squared and then a number on the end, sometimes you have a coefficient out front. This is considered vertex form. I don't have to really calculate anything to find the vertex. I can just look at that and find the vertex. So what you'll be required to do today is to find the vertex, the x-intercept, the y-intercept, and then go ahead and graph your function. So let's start finding the vertex. So your vertex, to find the x of the vertex, all you're going to do is take this right here, you're going to set it equal to 0. Subtract your 4 from both sides, so x equals -4. And then to find the y-coordinate of your vertex, just like when we were graphing those absolute values, this number right here, that's the y-coordinate of your vertex. And that's it, -4, 4. Now to find your x-intercepts, We're going to go ahead and solve this by taking square roots. So x-intercepts, when you find your x-intercept, what you do is you replace your y with 0. So we all know that f of x is really just y. So what we're going to do is we're going to take this equation, and instead of having it equal to f of x, we're going to have it equal to 0. Okay, so we're going to do the same thing we did yesterday when we solved by taking square roots. Instead of isolating our variable that's being squared, we actually have a quantity that's being squared now. So you want to isolate this part of it first because that's what's being squared. You want to get that all by itself. So you're going to want to take and subtract your 4 from both sides. So we end up with negative the quantity, x plus 4 squared. These are going to cancel, equals negative 4. Okay, it's still not by itself yet because we have a negative out front. So we're going to divide by negative 1. Those are going to cancel. We have the quantity x plus 4 squared equals positive 4. Okay, so now we're ready to solve and take the square root. So this whole quantity is being squared. So I need to undo this power of 2 before I can get rid of this 4. So you have to take the square root here and the square root here. And then don't forget, when you're taking the square root, the answer on the other side is always going to be that plus or minus. Okay, so this radical and this power, they cancel each other off. So we're just left with this x plus 4. And the square root of 4 is 2. So this is going to be plus or minus 2. And then we want to subtract 4 from both sides in order to get x by itself. So we have x equals negative 4 plus or minus 2. Okay, this is going to represent two answers here. So you have x equals negative 4 plus 2, and you also have x equals negative 4 minus 2. Because that plus or minus 2, that actually represents two different numbers, positive 2 and negative 2. And then you just figure these out. So x equals, well, negative 4 plus 2 will give me negative 2. X equals negative 4 minus 2 is negative 6. Okay, and those are your two x-intercepts. X equals negative 2 and x equals negative 6. So we're going to go back to our graph and we're going to put a dot on the x-axis at negative 2 and negative 6. Okay, and then the last thing I'm going to have you do is to find your y-intercept. So in order to find your y-intercept, oops. Bear with me here a second. There we go. Okay, in order to find our y-intercept, you're going to put zeros in for all your x's. Okay, so you're going to take and rewrite this equation, replace your f of x with your y. So y equals the quantity of x negative quantity x plus 4 squared plus 4. You're going to put a 0 in for all your x's because we're looking for a y-intercept. So for your y-intercept, x is 0, and you have to find out what the y is. Y equals negative quantity 0 plus 4 squared plus 4. From here, you're just following your order of operations. Okay, so 0 plus 4 is just 4. Y equals, you got to be careful here. This power of 2 is only attached to this 4. You're not squaring the negative. So you square the 4 and then the answer is going to be negative. So this does not go positive because of this here. This power of 2 is not attached to the negative. So it's going to be negative 16 plus 4, y equals negative 12. So my y-intercept is going to be 0, negative 12. Well, as you can see, that's going to fall off our graph. If you can't plot the y-intercept, that's okay. I still would like for you to find it algebraically. You should be able to give me all these answers algebraically. You will definitely be able to plot the vertex and the x and y intercepts for these. I made sure that they all worked out well. And the y-intercepts fall off sometimes, but doesn't mean you're not going to find it algebraically. I want to see this work. All right, and then if you want, you don't have to find any other points. You could, if you want, find another point here, in here if you want, see what's happening at negative 5 if you want to make a t-chart, but I'm not going to require you to do that today. Just going to draw a parabola. And remember, it's a parabola, it's a curve, it's not a V like your absolute values are. Okay, I have one more example to go through with you. Okay, so again, we're going to go through, find the vertex first. So for this one, I can just look at this. My x of my vertex is the number that makes this 0. So it's going to be negative 1. And the y-coordinate of the vertex is just this number that hangs out on the end. So I'm at 0, negative 2. Sorry, negative 1, negative 2. Okay, and then we're going to go ahead and find our x-intercepts. So what you're going to do for that is you're going to take your equation, you're going to set it equal to 0. Okay, you're going to solve by taking square roots because this is in vertex form. So we want to get this part by itself first. So undo any addition or subtraction first. So you want to go ahead and add 2 to both sides. So we end up with 2 times the quantity of x plus 1 squared. These are going to cancel, equals 2. Divide both sides by 2. Now we have that quantity isolated. Now we can go ahead and take the square root of both sides. So that just leaves me with x plus 1 over here equals, don't forget, plus or minus. So plus or minus 1. Subtract 1 from both sides. These cancel, so x equals, and then just for a minute, write it like this, negative 1 plus or minus 1. Okay, and if you can see what the answers are from there, go ahead and write them down. If not, then you want to set up 2 little expressions. So this represents 2 different answers here. X equals negative 1 plus 1, and then x equals negative 1 minus 1. So for this one, negative 1 plus 1 is 0. For this one, x is negative 2. Okay. So then you go to your graph, 0 and negative 2. Okay, and then the last thing I want you to find is your y-intercept. Okay, so for your y-intercept, you're going to put zeros in for your x's. So first, just go ahead and rewrite your equation. Y equals 2 times the quantity x plus 1 squared minus 2. Okay, and then we're going to go ahead and put in zeros for our x. Okay, simplify that. Y equals 2. 0 plus 1 is just 1. Okay, and again, when you're squaring, you're going to follow your order of operations, so you got to do your exponents first. So you're going to take and square the 1 first. You are not squaring the 2, and you are not multiplying 2 times 1 first. The very first thing to do is to square the 1. So y equals 2 times 1, because 1 times 1 is just 1, minus 2. Y equals 2 times 1 is just 2, minus 2. So y equals 0. So your y-intercept is going to be at 0, 0. And then you go over here. Well, look at that. We had our x-intercept there as well, so that makes sense. And then you just go ahead and graph your parabola. Okay, just make sure it's a nice smooth curve. Do your best. All right, there are two pretty good examples, I feel. Your problems for practice today are very, very similar to these. So please make sure you're showing the algebra for everything. I don't want to just see the graphs. Show the algebra for everything. All right, email me if you have any questions. Have a great day.